Thank you. So now at this time, please mute your mics for best sound experience. Otherwise, the feedback could interfere with information we will be sharing today. So without further ado, here is our presenter.
Welcome, everyone. My name is Ruben Carrizales. Thank you for that introduction. And I want to thank all of our students that are joining us today. We love to have you. Welcome. I'm so happy that you made it on a Friday. And also, before I forget, I also want to wish all of you a happy Labor Day weekend. Just to keep in mind, this coming Monday, there are no classes. Okay, so we all have a 3-day weekend. So I hope some of you guys are happy about that. So today, there's only one session since both classes, the Math 1314 and the Math 1324, coincide with the material. We only have one session, so we'll be handling both classes at once today. Okay, so today's topic is evaluate combinations of functions and composite functions. So please, if you have any questions, raise your hand or put your questions on the chat. All right, so let's go ahead and get started. So first, let's look at the notation for a function. Okay, so we have been to this point, you've been seeing equations of lines or just general equations, several different equations. But now when we look at functions, we're going to replace the y variable with f of x. And again, we read this as f of x, f parentheses x close parentheses. So as an example to one of the equations that, again, you've seen up till now, you have this quadratic equation or this equation that it's y equals x squared minus 2. And to convert it into a function expression, we're going to replace the y with this f of x. Okay, so when we read this, we know that this equation is a function. All right, so let's go ahead and evaluate the function for x equals -2. So again, keep in mind we started off with an equation, and to help you out, if you ever given the equation that has the f of x already notation, just so you don't, there's no mix-ups, you can always convert it back to the original y equals, right? So that's what we've done here. We have y equals x squared minus 2. So to evaluate this equation, we're going to replace our variable x with our value -2. So everywhere we see x, we're going to plug in this -2. Okay, so one of the things that you would like to, or we would like for you guys to consider when we're looking at functions, is our x value is going to be this input value that we're going to put into this machine, right? We're going to put it into this output generator, and our output is going to be, our y value. Yes, so when I plug in this -2, again, we like to consider it as our input. What will be our output? And again, it's by replacing the variable x with the value -2. So to process this, we take the square of -2, which is going to be a +4, and then 4 minus 2, we're going to get 2, right? So we have 4 minus 2, and 4 minus 2 is going to give us our y equals 2. So our output result is this value 2. So we have this ordered pair for this function where our input, which is an x value, is -2, gave us an output of +2. Okay, and again, this is an ordered pair of the function. All right, so if I would ask you, well, what does f at -3 mean? Well, again, what that means is we are going to now evaluate our function, and -3 is our input value, and we want to get an output, right? And we're going to get a y value as an output. So again, if we were going to evaluate this, everywhere I see x, I'm going to replace it with -3. And again, if you notice on this time around, I didn't convert it back to an equation, just so you can see what this meant, right? That f of -3 means that everywhere I see x, I'm going to plug in -3. So when I do this, -3 squared is going to give me a positive 9. And 9 plus 2 is going to give me 11. That is my output result. So my ordered pair for my input -3 is an output of a positive 11. Okay. All right. So let's do a few more of evaluating, just basic evaluating functions. So let's say we have this function, the square root of 3x minus 2. And we want to evaluate these three input values, right? This A, B, and C. So let's start with A. A is x equals 2. So again, if we were writing the syntax, keeping the function notation, we have f and our input is 2. So that means, again, everywhere we see x, we're going to plug in a 2. Okay? So all right, so parent functions, okay, we'll touch a little bit on this, Ms. Loya. Um, the parent functions are the functions that can represent all of our functions or any function that we can think of, right? Our parent functions are the ones that if we know these, we know the graphs of the functions, we know the behavior of those graphs, and they all work the same way. If we're evaluating any type of function, when evaluating functions, it's this same way. We're going to have an input value, and to that function, when evaluated, we're going to get an output value. And again, we're going to get an ordered pair of that function. Am I answering your question as far as in relation to parent functions? Again, awesome. Okay, again, yes, they work the same way. Um, So let's go ahead and continue with this example. So we have the square root of 3, the square root of 3 times 2 minus 2. And again, I have my parentheses because I apply the 2 just only to the 3. So 3 times 2 is going to give me 6. And 6 minus 2 is going to give me the square root of 4. And the square root of 4 is going to give me 2. So again, when I had an input of 2, my output, which is this y value, is going to be 2. So let's go ahead and do B now. It wants me to evaluate the function for my input value A. So again, this means that I want to evaluate f at A. So everywhere I see x, I'm just going to replace it with A. So we have 3 times A minus 2. And this one's very easy because there's really nothing that I can simplify. Once I multiply that 3 times A, I can't simplify anymore, right? So this would be my answer. And this is the answer that the computer would want to see. It would want to see the output of the value A is the square root of 3A minus 2. Again, we cannot simplify this any further. So let's go ahead and do C. So C has 6 plus h. This one's a little bit tricky or a little bit more complicated. So my input value is 6 plus h. So I'm going to evaluate the function at this input value, 6 plus h. So everywhere I see x, I'm going to plug in 6 plus h. Yeah, so we have the 6 plus h here. So I say it's a little bit more work because what I need to do now is I need to distribute this 3 to both of these terms that are inside this parentheses. Again, I'm going to fill it in, right? 3 times the 6 and 3 times the h, okay? All right, so then 3 times 6 is 18, and 3 times h is 3h, and I have just a minus 2 here. So I'm going to combine my like terms. So I have two like terms, which is I have two constant values that don't have a variable associated with. I have this 18 and the negative 2. So 18 minus 2 is going to give me the 16. So the output when my input was 6 plus h, again, we're going to leave it like this because we cannot simplify it any further. We have the square root of 16 plus 3h. Yes? All right. Any questions? So All right, so another function that we want to talk about that we sometimes see our students struggle with is this type of function, which is called a piecewise function. And the reason why it's called a piecewise function is because we have this function that is made out of several pieces. And in this case, and this example is made out of two different functions. So if we look at this function here, we have a linear function, and then we have this more complicated function that we will later in class look further into detail, but this is a quadratic function. But these are two different functions, and what the way we read this piecewise functions is that this function is only valid for this restriction, for this domain, right? That the x values that this equation we only want to consider are the values that are going to be less than -1, okay? And in order for us to consider this function, the x values that we only want to look at or consider are the x values that are either greater than or equal to -1, okay? So let's go ahead and evaluate this piecewise function. So A, here we have they want us to evaluate f at our input -4. So then I have to say to myself, okay, is -4 greater than or equal to -1? Well, the answer would be no, right? So we need to decide which function to use, right? Which equation of the piecewise function we need to use. So obviously we're not going to use the second one because -4 is not greater than or equal to -1. But -4 is less than -1. So this is the function that I'm going to use for this input. So when I evaluate, my function is going to be this one, -2x minus 2. And again, my input value is going to be the -4. So everywhere I see x, I'm going to plug in that -4. So we have -2 times -4. A negative times a negative is going to give me a positive. 2 times 4 is 8. So we have 8 minus 2, and 8 minus 2 is going to give me 6. So again, we don't have multiple answers for these, okay? It's always going to be one answer. So our ordered pair is going to be -4, 6. When my input was -4, my output was 6. So let's look at B. Which one are we going to use for -1? Now, -1 is not less than -1. -1 is equal to -1, right? So the right function to use or equation is the second one, right? Because -1 is greater than or equal to -1. So the one we're going to use is this one. So let's go ahead and apply it. Our function that we're going to use is x squared plus 2x minus 1. I'm going to evaluate it at my input -1. Everywhere I see x, I'm going to plug in a -1. On this particular one, I have two instances of x, right? So we have -1 squared plus 2, another x here, so it's a -1 minus 1. So if we evaluate -1 squared, that's going to give me a +1. 2 times a -1 gives me a -2 minus 1. So we have 1, +1 minus 2 is a -1, and a -1 plus a -1 is a -2. Again, my input value was a -1, my output value is a -2, and that is my ordered pair. So let's go ahead and look at number C, or letter C, excuse me, not a number, but letter C. So letter C, it wants us to evaluate the function at 1. So which one would we use? 1 is not less than -1, right? But 1 is greater than or equal to -1. So again, we're going to use this one again. We're going to use x squared plus 2n is 1. So let's go ahead and do that. So we're going to use x squared plus 2x minus 1. Again, everywhere I see x, I'm going to plug in a +1. So we have 1 squared plus 2 times 1 minus 1. So 1 squared is 1. 2 times 1 is 2. Then we have minus 1. So 1 plus 2 is 3. And 3 minus 1 is 2. So when my input was 1 for this piecewise function, my output was 2. Okay. Any questions on this piece on piecewise functions? All right, awesome. So let's go ahead and move forward. All right, so when we're talking about functions, and you heard me say this when I started talking about my piecewise function, our domain is very, very, very important, okay? Our domain refers to our input values, okay? So domain refers to all the x values that a function has. And sometimes we will have restrictions on our domain. There's some particular functions that there's some certain x values that we cannot put in, okay? So let's see an example here, okay? So if we have this graph and it's a line, again, we see that it's a positive slope line, right? It's pointing upwards, okay? And if I was to read the graph, again, as a review, when we read graphs just the same way we read our textbooks or we read our English books, right? We read from left to right. So when we read this graph from left to right, okay, we are looking at all the x values that this graph can have, right? And the arrows indicate that this graph is going forever up, and the arrows down here indicate that it's going forever down, right? So what this means that our our x values that are used on this graph are all the values, right? So it's from negative infinity to positive infinity. Again, we read graphs from left to right, so it's going forever to the left and it's going forever to the right. So the domain for this function is all real numbers, right? So again, and if we were going to write this on interval notation, we will write using we will write using the infinity. And again, if it had shown me it was all the x values, right? It's all the x values associated with this graph. Okay. All right. So does the equation have a there does the equation have a fraction that has a variable as a denominator? So I was telling you all that there's several functions that we have to be careful with our domain, with our x values that we need to put. And one of those are functions that have a fraction in them, because as you all know, when we're dealing with fractions, we never want our denominator, the number on the bottom, to ever be equal to 0. Because again, if we were to plug that into our calculator will tell us that this function is undefined, that we cannot do it, right? It will get an error. So this is one particular function that we have to be careful with our domain, okay? So if you have a function that has a fraction in it, be careful. We would have to be specific and make sure that our denominator is never 0, or we never input the value 0 for it to evaluate. Okay, so the other function that we have to be very, very careful on is square roots. So to review the square roots, we never want to have negative values. We never want to evaluate negative values for square roots, okay? In the meantime, we will be dealing more in detail with square roots. And when we have negative numbers, we come up with imaginary numbers. But at this point in time, if we were to plug in a negative value to our square root function or operator, the calculator is going to tell us undefined, or we're going to get an error. So these two particular functions, we have to be very careful with our domain. We never want either a 0 for our fraction functions, or we never want a negative value inputted in our square root functions, okay? All right, so we also, there's one more, and we will be dealing with those in our classes as well, is whenever we deal with logarithms, okay? So logarithms have also a restriction on them, again, and when we get to them, we will see these a little bit more in detail, okay? So again, if we can answer no to any of these three questions, then we can for sure, without any hesitation, any function that they give us that does not have either a fraction or a square root or the word log on it, our domain will always be all real numbers, okay? And again, in interval notation, it's from negative infinity to positive infinity, means that it's all of the numbers to the left and all of the numbers to the right, okay? All right, so let's go ahead and find the domain of each of these following equations, right? So we have the first one. Let's do A. A is equal to y equals x plus 5, okay? So right, the first thing that I want to look at is there is no fraction on this equation. There is not a radicand on here, so the answer is no, right? So we know that the domain is going to be all real numbers. So our answer is from negative infinity to positive infinity, okay? And that easy. If you can answer no to these three things, this will be always your domain for these types of equations. Okay, so let's look at, so if we were to graph it, okay, this tells me that my y-intercept is at 5, okay, my slope is 1, so it's rise 1, run 1. So again, it produces this line, and we could see, right, that the domain, just like before, we have arrows pointing to the left and pointing to the right forever, right? So this is our domain. All right, so let's look at B, okay? So B, we can answer right away that our domain is from negative infinity to positive infinity because, again, we've answered no to our three questions. We don't see anything with a fraction. We don't see anything with a square root. And we don't see anything with the word log on it, yes? So if we were to graph this function, okay, again, we have arrows, again, on both sides of my graph that are telling me that this graph goes forever to the left and goes forever to the right. Okay? All right. So what about, oops, this should be C and D, right? So on this particular one, what do we see here? We have an X on the bottom that has it's a denominator of a fraction. So on this particular one, we know that when we're dealing with a fraction, we never want 0 as a value in our denominator as of a fraction. So for this particular equation, okay, we can put any single value for x except that 0 value, okay? So then when we're going to write our domain, this particular equation has a restriction, this 0. So the syntax for it is going to be all, or the English words is going to be all real numbers except for the value 0. But in interval notation, okay, again, when we write intervals, we write them, again, from left to right. We start with the smallest. We have from negative infinity all the way up to 0. And we use parentheses, okay? So the parentheses, to do a little bit of review of interval notation, parentheses means that we don't include the number, okay? It's because infinity never stops, right? So we always use a parentheses when we are using it with the symbol infinity. And on here, we want to stop at 0, but because I use the parentheses, that means that I stop at 0, but I'm not including 0. And then we have this little symbol that looks like a U, okay? And that's actually the interval notation name. It's union, or the and, okay? We can say it as an and. So these are all the numbers to the left of 0 and all the numbers to the right of 0. And again, interval notation is I pick up at 0, not including 0, all the way up to positive infinity. Okay, and again, we have a parentheses because infinity is not a symbol. It's a number that keeps on going forever. Okay. All right. What about my f? Okay. The same thing with my f. I had a portion of my equation that had a fraction on it. So I never want this bottom part, this x minus 6, to ever become 0. So if we don't see it, we can solve for it, right? We can say to ourselves, will ever x minus 6 equal 0? So if we do a little bit of algebra, solve for x, add 6 on both sides, we can see that if I ever put the value 6 down here, and we can see that if we have 6 minus 6 is going to give me 0. So this particular equation has a restriction. We do not want to include um, the value 6. So that is my restriction. So in interval notation, we're going to look at all the values to the left of 6, so it's from negative infinity to 6, not including 6, and or union from 6 to positive infinity. Okay, so keep in mind that WebAssign, when dealing with domain, most of the time is going to ask you to write it in interval notation, your domain. Okay. So if I were to graph it so you can better see why we're not including these values, okay, the graph of this function is, as you can see that it goes forever to the left, and then it gets very, very close to this value 0, doesn't touch it, okay? Again, we're going to be dealing with these types of equations and functions later on to in our class. For the time now, I can tell you that this is an asymptote, okay? This is an imaginary vertical line that this graph never touches or crosses, okay? And then it picks up on the other side. It jumps, and then it's coming from the infinity, the positive infinity, and then it never crossed or touched this line, and it's going forever to the right, okay? And if I look at this last one, okay, we have the same situation going on, okay? We have this imaginary vertical line at the value -6, or x equals -6, where this graph never touches or never crosses. So it's from coming from forever to the left, close to the 6 value. Um, I'm sorry, this graph should be on the other side, okay? My apologies. Okay. All right, so let's go ahead and find the domain on these. Again, if we see, we have a restriction again. The two previous ones, we had fractions, but now we have square roots, right? We have radicands on here. So on this one, let's do this first one. We never want a negative value inside our radical. So our restriction for A is going to be all the numbers that are greater than 0, right? So if we want all the values greater than 0, okay, this is how we write it. X has to be greater than or equal to 0. So the way we would write this in interval notation is we want to start at 0. So the symbol or the notation for interval notation, where we say that we do want to include the number, is a bracket. Okay, the bracket symbol tells us that we can start there, and we do want to include it, and it's going from 0 to positive infinity. Again, the infinity symbol, since it's a number that's going forever, we'll use a parentheses. Okay, let's look at the B. Okay, we never want our value in here to ever become 0. So if we can't see that direction, okay, we can solve for it, right? We would set x plus 5 has to be greater than or equal to 0. So let's solve for x. So the first thing that I'm going to do is I'm going to subtract 5 on both sides. So what this is telling me is that x has to be greater than or equal to -5. So how do we write this? Again, I start at -5. X has to be bigger than -5. So I start at -5, but I can include it. So I'm going to use a bracket, and I'm going to go forever to the right. And I use that using the infinity symbol. And again, parentheses. Okay. So thank you, Ms. Chuko, for answering all those questions on the chat. Any questions so far? All right, let's go ahead and keep on moving forward. All right, so if we were to graph these so you can see what we're talking about, okay, on this particular one on A, we have a graph that starts at 0 and goes forever to the right. Okay, so again, this is my domain. It's telling me all the x values that this graph has, okay? And if I look at this one here, okay, at -5, I start at -5, and it's going forever to the right, okay? So the domain is telling me all the x values that the graph has, okay? All right, let's move forward. All right, so evaluating functions graphically, okay? So let's look at this particular example. Okay, so we have an example here that we have this graph that looks like a W. So before I start evaluating, let's take a little bit more detail on the graph here. Okay, so when you have an open circle on the graph, again, what this means is the graph starts here, but I do not want to include this point here. Okay, this y value. Okay, when we have a filled circle, okay, I want to include that value. That means that this value is included in part of this equation. So to get an idea also, it's in reference to our interval notation. Whenever we're using parentheses, we have an open circle happening. When we have a bracket using in our interval notation, we have a filled circle happening in our graph. Okay, so let's go ahead and do A. Let's evaluate A at -1. So remember, this -1, this function at -1 is my input value, hence my x. I want to evaluate the value um, at x equals -1 on my graph. Okay, so when I do that, um, here, okay, and I'm here, let me go back because I'm going a little too fast. So if I'm evaluating f at -1, okay, I want to know what the value at -1 is for my graph. Okay, so what I would do is I would come to my x value -1 and see what does this value correspond with the y value. So I would go down here and I see that it looks like about a -4. Okay, so but before I continue again, let me have what I have on my slides. Okay, so again, the domain refers to what I had already said, right? The domain refers to all my x values. So when I'm evaluating a function, I'm wanting to see what that x value corresponds into my graph. And to add a little bit more terminology, okay, when we're talking about the x values, okay, we refer to that as domain. And we had mentioned that our output are our y values. So when we're evaluating functions, our our math terminology for our y values in a given function are considered our range. Okay, so um, our domain for, if we were looking at this um, graph right here, again, I mentioned to you here that we have an open circle and it's at the value -2, so I use a parentheses, right? And this graph is going all the way up to +2, okay? But I have a fill circle, so again, I'm putting in a bracket. And like I said, I'm I said it before you all read it and saw it. Okay. All right. So let's go ahead and continue evaluating our functions that we have. Okay. Oh, and let me talk about, since I talked about my domain, let's talk about our range. Okay. So our range has to deal with all our y values. Okay. Now, as you can see here, our smallest y value is -4, and it is including it. So again, we use a bracket. Now, the top portion, even though this side is not including the +5, this side is, right? And that's what we're interested in. We are interested in is what's the last value or the last given value that the graph has. So this 5 is included, even though it's only on one side, the highest point is this +5. So we would put it here as a bracket, 5. And again, we read graphs from left to right, and if we're doing the range, which is the y values, we read them from up down, or think of it, you're laying on your bed and reading the graph on the side. Yes. All right. um okay, so again, I had done the first one when I said what is the value of y when my x is -1, and again, when I go into my graph, I see here that my y value is about a -4. What about 0? What is the value for y when my x is 0? So if I look here, here is 0, and I go down, I'm looking at -3, right? So how about 1? If I want to evaluate what is the value when x is 1, okay, when I go, this is the value 1 here. If I go down here, looks like it's -4 again, yes? And the last one, I want to evaluate f at 2. My value 2 is this x, right? So here at 2, I go up, and it's the value for 5, right? So this is evaluating functions graphically. Any questions? All right, great. Let's go ahead and continue moving forward. Let's look at this example, okay? Now, on this particular one, normally when you see this graph on the computer, you're not going to see this little arrow, but that's what the computer means. Okay, if you see a line that ends at the graph, because this means that the graph is going forever down or forever up. Okay, so I went ahead and put this arrow on here just so you all know that if I were to answer the domain and range for this graph, again, the domain for this graph, again, reading it from left to right, the first value here that I come up with on the left is a -1. And because I have an arrow on the right side, I'm going to say that this graph is going forever to the right. So my domain for this graph is going to be from -1, including -1, to positive infinity. Well, what about my range? Again, my range, we're going to read them from bottom up. So because the arrow is pointing down, my first value is the negative infinity, right? And again, we're going to use parentheses for the negative infinity because it's not a number. And what is the highest y value that we have? And we see that the highest y value here is 7. Even though it's not a dot or anything, we know that the graph, since it's a solid line, it is including this highest point, which is 7. So my range in interval notation is again from negative infinity to positive 7. Again, the 7 with a bracket because it's being included. So let's go ahead and evaluate these values. What is the y value or output value when my x value is -1? So I go to the value -1, and again, at -1, we know that that value is 4. Yes? So let's look at 0. What is the value for y when my x is 0? So here we have 0 for x. I go up to my graph. It looks like it's a positive 3. Yes? So what about 1? What is the y value when my x value is 1? When my input is 1, my y value looks like it's going to be 6, right? And what is the y value when my x is 2? So when my input x is 2, my y value looks like it's going to be that 7 value, right? So again, this is how we evaluate functions graphically, okay? All right, let's do this one, okay? Let's go ahead and find the domain and range of this graph, and then we will find the indicated values. So we have this graph. If we're looking at the left, we have the graph that has an arrow. Again, we added this just so you can see that this graph is going forever to the left. Okay, so as we look at the graph from left to right, okay, we see here at 1 we have a solid circle, right? So it's including at -1. Even though we have an open circle here, okay, we know that there is a value um, for 1 on our x. So again, we're interested in the x values, okay, because we're talking about our domain. And then it goes on from 1 to forever to the right. So our domain for this particular graph is from negative infinity to positive infinity, okay? But what about our range, okay? Let's look at this graph from bottom up, okay? So on this one, our lowest point here is at -2, but we do have an open circle. So that means we're going to start at -2, but again, the symbol that we're going to use is this parentheses because we want to start here, but we're not including -2. And both of them have an arrow going up, so that means that this graph is going forever up. So our range would be from -2 to infinity, again, not including the -2. So let's go ahead and evaluate these values. Let's start again. F at 2. So I go to my x value 2. What is the y value associated with this graph? So here it looks like the line is going through the x-axis at 2. So we would say that our y value is 0. Okay. What about 1? Oh, this one's easy too. At x equals 1, our graph starts here. So we're going to say that our y value is also 0 for this particular one. Okay, what about at x equals 3? So here's 3, positive 3. So I go up to where the graph is, and it looks like that's a positive 2. We're at 3. So I would say that would be 2. Okay, and then the last one, what is my y value when my x value is negative 1? So I go to the negative 1, go up to where my graph is, and I'm going to say that's about 2. Okay, so I'm going to guess it's 2. And yes, so um, again, this is how we evaluate functions graphically. Okay, our function input value is referred to our x, and we want to find what the y value is according to our graph. All right, so let's graph piecewise functions. Again, piecewise functions are those functions that are made out of several parts. Okay, so let's look at this particular one. Now, something that I didn't mention, and please, and I'm glad it came up with this example. Okay, normally, as when we started talking about functions, we took off the variable y and replaced it with f of x. But that's just a name, okay? It's we like to use f because f for function, but it's just part of the name. It's still a function. So the syntax you're going to see a lot, especially on your computer work. The computer likes to use h of x. This is still representing a function. It's called h instead of f. Okay, so this is one of the most common ones, the h. You'll hardly ever see m because again m we have for slope. You won't see x again because we already have it designed for our x values, but you'll see n's, and I think K's and L's are used a lot as well. Okay, so this is just a name. Thank you, Ms. Chuka. You'll see T's and S too a lot when talking about functions. All right. So again, just to review this piecewise function, this top portion of the equation refers to my domain of all the positive values, right? All the values that are greater than 0. When I'm interested in this graph on the bottom one, all the x values are, excuse me, less than or equal to 0, okay? So when we graph, it's good to go ahead and build a table, okay? So let's see. We need to decide what values to use. And again, our restriction on our domain will decide on that. So for this first one, so for x plus 4, since I only want to use values that are greater than 0, so there's, I don't want to use -1, I don't want to use -2, things like that, right? We want to use only positive values. So I can pick any value that I want in order to evaluate this one, right? So again, always be nice to yourself, pick easy numbers. Okay, so I'm gonna choose 1 and 2, right? And 0, okay, 0, well, actually we can't use 0, why? Because it says just greater than, right? So we cannot use 0 because it says not use 0 on this one, right? We only want values greater than 0, okay? So let's go ahead and evaluate the at 1, right? So when we have the value for 1 on our first one, 1 plus 4 is going to give me 5. For x, 2 plus 4 will give me 6. Okay, all right. What about for the x? Okay, so again, the x, I want to use values that are less than 0. Okay, so easy numbers. Again, -2, -1. On this particular one, I do want to use 0, right? Because it's part of my domain, right? It says that I can include 0. Okay, so here, when I plug in -2, my y value is going to be the same, right? -2, -1, and 0. Now, again, what we did here is to represent the 0 as an open circle, right? What this would indicate. When x is equal to 0, I'm going to get a value for y, which in this case is 4, but it would be my open circle, right? So here, the value that I have for 0, because it's equal to, means that I am including this value. So this will refer to my filled circle, okay? All right, so if we were to graph these, okay, let's go ahead and plug them in, okay? So we can do our fill circle. We want to include that one, right? When we have x equals 1, our y value is 4, okay? I'm sorry, 5. When x equals 2, my y value is 6, which is here. So we have the 5 in blue and the 6 in green, okay? And then we can connect them with a line, right? We connect the line, including at the open circle, and it goes forever up, right? And we basically just need 2 points, right, to do a graph. Let's do the other part. So to graph x, again, when x equals -2, okay, y equals -2, indicated in purple. When x is equal to -1, y is equal to -1, here indicated in black. And our filled circle, when x is equal to 0, y is equal to 0, and it's indicated like this pink color, right? So to draw our line, okay, we start from our 0 and then connect them. And again, this graph is pointing forever down. So this would be our graph of this piecewise function. Okay. Any questions? All right. So let's go ahead and sketch this one. I want to move a little bit faster because it's like I want to try to get as much of our presentation as possible. So let's sketch this graph kind of quickly. Again, we have restrictions on our domain. Again, we have for the first one, all the x values that are included in this equation are less than or equal to -2. All the values for x that are included in this equation, our domain, are all the values that are greater than -2. Okay, so when we do this, okay, again, we want to do our table. Okay, we want to pick values that are applicable, and we want to be nice to ourselves. We want to use somewhat nice numbers. And again, went ahead and plugged in those -2s, okay? Because again, on the first one, and now it's backwards. The first one has a fill circle. The second one now, because there's no equal sign, we're looking at an open circle, okay? So let's go ahead and plug them in. So when I have x equals -4, my y value is 3. When x is -3, my y value is 4. When x is equal to -2, my y value is 5. And for my second equation, again, when x is equals -2, my y value is -3. When x is equals -1, my y value is -5/2. And when x equals 0, my y value is -2. Okay, all right, so if I were to plot these points, okay, let's look at the first part, the x plus 7, okay. When x equals -4, we have a +3. Let's see here. -4, +3, which is again in like a pink color, I want to say. When x is equal to -3, we have a +4, which is in blue, and the -2 gives me this 5, which is in my green. Okay, and to draw the other side, okay, when x equals -2, I have a -3. Okay, and again, this is my open circle. When x equals -1, my value is -3/2 in between this 2 points here, roughly, okay, labeled in black. And when x is equal to 0, my y value is -2. Okay, and then I connect the dots. All right, so I do have 10 minutes, so let's go ahead and touch on combination functions, okay, which is adding, subtracting, multiplying in functions. Okay, so given these two functions, f of x and g of x, to add them, this is what you're going to see on the computer. Okay, this is the syntax. I want to add function f with function g, and it's basically very straightforward. I like to rewrite it so I can really understand what's happening. And really what's really happening is you're just adding these two functions. You grab function f and you're going to add function g, and you're going to go ahead and combine the like terms. Okay, same thing with the subtraction. So let's go ahead and do the addition first. So the first thing I would do is I would write function f of x, which is 3x minus 7. I'm going to add that with function g, which is 4 minus x. Again, and then it's now just combining my like terms. So I have a 3x with the x. So 3x minus x is going to give me 2x, and minus 7 plus 4 is going to give me a negative 3. So the addition of function f with function g is just 2x minus 3. Okay, this is straightforward. So again, the syntax for subtracting functions, I like to rewrite it and say it's just f of x minus g of x, and let's substitute. F of x is 3x minus 7 minus g of x, which is 4 minus x, and I'm going to put a parenthesis because I have this negative symbol, right, that I'm going to have to distribute. So I'll have to distribute this negative. Negative times the 4 is going to give me a negative 4. And negative times the negative is going to give me that positive x. So 3x plus x is 4x. And minus 7 minus 4 is minus 11, right? So we have 4x minus 11. Okay. Multiplication of functions, right? The syntax that you're going to see on the computer is just next to each other. This means multiplication. But basically, what you want to do is just do that. You want to multiply function f with function g. I rewrite it. And then let's just go ahead and substitute. Function f is 3x minus 7. Function g of x is 4 minus x. So basically on this one, we're doing FOIL, right? This term has to be multiplied with this term, and this term, the negative 7, has to be multiplied with this term and this term. So when we do that, 3x times 4 is a 12x. 3x times a minus x is a minus 3x squared. Minus 7 times a positive 4 is a minus 28. A negative 7 with a negative x is a positive 7x. We combine our like terms. Well, there's nothing to combine, so you can leave the answer there. But we always like to have it in standard notation, which is our highest exponent variable first, right? So we write it as negative 3x squared. Oh, sorry, and we do have some like terms. We had the 12x and the 7x. 12x plus 7x is 19x, right? That gives me my middle term, and the constant negative 28 didn't have anything to add with, or the negative 3x squared. All right, the last one, which is the easy one, the f divided by g of x. Okay, we rewrite it. All this is saying is we want to evaluate the function f of x divided by function g of x. Let's go ahead and substitute back what these are. Function f of x is 3x minus 7. Function g of x is 4 minus x. Now on this particular one, since I can't factor the top or factor the bottom, I can't simplify them any further. This is my answer. Okay, this will be my answer for the division of these two functions. But we want to take it also a step further, because on your homework on WebAssign, or if you're using MyMathLab 2, they're going to ask you what is the domain for this type of function. Again, because we have a fraction, there's going to be a restriction. And we covered this. We never want the denominator ever to become 0. So we see here that if we ever put in the value 4 for x, we have 4 minus 4, which will give us 0. So the domain for f divided by g is all real numbers except for the value 4. Okay. So again, in interval notation, it would be from negative infinity to 4, not including 4, union or and from 4 to positive infinity. Okay. All right. Any questions? I know I'm going kind of quickly. These are pretty straightforward. So let's just practice a few more of just a combination of functions. Okay. Let's have this function f of x, which is x squared, g of x, which is 2x minus 5. Let's add f plus g. So again, we're just adding these two functions together. Substitute. F of x is x squared, g of x is 2x minus 5. There are no like terms on here, so that would be my answer. I can't simplify any further. Okay. How about the the subtraction, okay? Subtract f of x with g of x, okay? We have to worry about this subtraction symbol. It's our negative that we have to distribute. A negative with a positive 2x is going to give me a negative 2x. A negative with a negative 5 gives me a positive 5. Again, there is no like terms that we can combine, so that would be my answer. X squared minus 2x plus 5. Okay, let's do the multiplication one. Okay, we want to multiply f of x with g of x. So we have x squared times 2 minus 5. Again, we're going to do FOIL. We're going to distribute this x squared to both of these terms. X squared times 2x is going to give me 2x cubed. X squared times a negative 5 is going to give me a negative 5x squared. Can't simplify. There's nothing more to combine. So that is my answer for f times g. Yes? And last but not least, the easy one, f divided by g. I want to divide function f with function g. So function f is x squared, function g is 2x minus 5. Again, I can factor this, right? There's an x here, but this term only has one x, so I can't factor an x. So that's simplified already. So that would be my answer. But again, WebAssign is going to ask me for the domain. So if I were to solve for this 2x minus 5, if I don't see it, will this ever give me 0? Using algebra, it's going to see that x equals 5 halves. If I ever plug in 5 halves for x here, this will become 0. So my domain is all real numbers except this 5 halves. So in interval notation, again, is from negative infinity to 5 halves, and from 5 halves to positive infinity. Okay, so this is the typo here. Let me rewrite this side. It should be like this. 5 halves to infinity. Okay, sorry about that. Okay, we were too much copy and paste. All right, I've got 2 minutes left, but I think I will stop here. Again, if you have any more questions, we encourage you to stick around. We have awesome tutors that are here to help you. Please don't forget to sign in. Some of your instructors give extra credit for attending these sessions, so please go ahead and sign in, do the survey. Okay, this for those who are new to our Happy Math Hour, this can also give you credit for the Tejano Passport. Okay, look into it if you all don't know what the Tejano Passport is. It's a great way in the end to come out with a medallion that you can wear when you graduate. Okay, so look into that. So thank you all for joining us. Ms. Chuka, do you have any questions, any comments for us?
No, just that next week we'll be covering an important topic that you'll use, especially when you start getting to the next chapters, which is factoring. We might be able to cover a few of these slides that we didn't finish today, but thank you all for coming, and we look forward to continue to see you every Friday. Have a great long weekend.
Thank you, Mr. Carrizales. Thank you, Ms. Chuka and Mr. Isasi. Thank you all for joining us, and I hope to see you all next week for factoring. I'll be stopping the recording now, and if you do have any additional questions, now's the time to ask. And once the instructors leaves, we also have tutors available if you have additional questions.